Recording in progress.
Hi students, in this lecture I am going to discuss problems. Let us see first one. Let's see the question given. A circuit is connected as shown in the figure with the switch S open. When the switch is closed, the total amount of charge that flows from Y to X is. So this is asked in 2007 for 3 marks. Let us see what he is saying here. Initially switch was opened. Now switch is closed. After closing, we have to calculate how much charge flows from Y to X, right? See what makes difference before closing and after closing. So before closing, you can see current flows like this. Because once these are fully charged, no flow of current through capacitors. Okay. So we are focusing in steady state. So current flows only like this. Okay. And after closing, see what happens after closing. So let us make a diagram first. Given 3 micro and 6 microfarad. Three micro and 6 micro. And connected to two resistors, 3 ohm and 6 ohm. 3 ohm, 6 ohm. And switch is here. And connected to a battery of 9 volt EMF. Right now, see carefully. So before closing the switch, so current flows like this. So current equal to, so what is the current? 3 plus 6, 9. And 9 by 9, it is 1 ampere, right? So first focus now, before closing, charges on capacitors. So you can see before closing, these two are in series combination, right? In series combination means effective value will be, say effective capacitance will be 3 into 6 by 3 plus 6. So it is a 2, right? So 2 microfarad effective value. And you can see between these 2 points potential difference that is equal to 9 volt. Okay, across these two 9 volt. And effective capacitance equal to 2. That means charge equal to Q equal to C into V. So 2 into 9, that is 18. So 18 microcoulomb. So since that series combination and initially uncharged, on each capacitor charge is same. It is 18 and 18. Okay. Now see carefully here. This is a plus 18. I'm writing here Q plus Q minus Q plus Q minus Q. If you observe carefully, what happens is electrons will move from this plate and they are accumulating now on this plate. So this is becoming positive and this is becoming negative. Okay, that is what exactly happens. Now coming to these remaining two plates, these two are not connected to battery. Okay, that means on these two plates, net charge remains constant. So here you can see minus and this is a plus. Means minus 18, this is a plus 18. So total value is 0. Okay, total value how much? It is 0 on these two plates. Now see what happens when switch is closed. When switch is closed, across 3 microfarad capacitor, across this capacitor, potential difference equal to potential difference across 3 ohm resistor. See carefully. Once the switch is closed, across 3 microfarad capacitor, potential difference equal to the potential difference across 3 ohm resistor. Okay, that means charge on 3 microfarad capacitor, charge on 3 microfarad capacitor equal to potential difference, current equal to. So before closing, after closing, no change in current, that is 1 ampere. So potential difference across 3 ohm, it is 3. 3 is 9. It is now 9 microcoulomb. See carefully. Initially charge was 18 coulomb. Now it is 9. And coming to on 6 microfarad capacitor, charge will be potential difference across this capacitor is equal to the potential difference across 6 ohm resistor. Okay. And across 6 ohm resistor, potential difference is 6 volt. So 6 into 6, it is 36. So 36 microcoulomb. Okay. Now see carefully these two inner plates. Okay. Only these two. Initially means before closing switch, minus 18 plus 18, total value 0. Now what happened is on 3 microfarad capacitor charge is 9. So plus 9, it is minus 10. I will draw separately here. See, this is 3 micro and this is now 6 micro. So here plus 9, this is minus 9. Next coming to 6 microfarad capacitor, it is plus 36 and this is minus 36. Now focus carefully. Again, those two inner plates. Again, those two inner plates. If you focus now these two plates, initially net charge was 0, right? So minus 18 plus 18, net was 0. Now present value, this net value, it is 27, right? Plus 36 and this is minus 9. So net value how much? Plus 27. That means how much charge has flown from Y to X. That is 27 microcoulomb. Okay. So our answer is 27 microcoulomb. Suppose question is asked like from X to Y. Okay. If question is asked like from X to Y, then answer will be minus 27. So we have to focus carefully. Are they asking from Y to X or X to Y? Okay. Let us see next one. Right. See the question. Find the time constant for the given RC circuits in correct order in microseconds. So asked for 3 marks in 2006. Right. See first one. So here V stands for battery. Okay. Given two resistors, two capacitors in all circuits. See, whenever we want to find out time constant, so first we have to focus across the capacitors. What is the equivalent resistance? We have to focus across the capacitor. What is the equivalent resistance? And for that, we have to short the battery. Short the battery means remove the battery, connect by conducting wire. Okay, that means remove this one and connect by conducting wire. Then see what happens. Across this combination, these two are in series combination. Okay. Next, in the same way, if you take here across this combination, these two are in parallel combination. So step 1, remove the battery. Step 2, connect by conducting wire. So across this combination, this is in parallel combination. And you can see here across this, it is again in parallel combination. Okay. Let us see calculation part. So see the first one diagram. So two resistors and there is a one battery here. And here two capacitors. So you can see R1, R2, R1, R2, C1, C2, and given their values, see values how much given? R1 is 1 ohm, and R2 it is 2 ohm, C1 4, C1 4 microfarad, and C2 given 2 microfarad. So now we have to focus across the capacitor combination. So these two are in parallel combination. So effective value is C1 plus C2, right? Parallel combination. C1 plus C2. Across this combination, these two are in series combination. So here what we have to do? Remove the battery. Connect by conducting wire. So series combination means effective value R1 plus R2. It is into 3. This is how much? 4 plus 2, 6, 6, 3, 18. So first combination it is 18 microseconds, right? Then see next combination. Next combination, voltmeter. So again here what we are doing is across the capacitor combination. Across the capacitor combination, what is now equivalent resistance? Okay. These two are in parallel combination across this capacitor series combination. So effective value C1 C2 by C1 plus C2 resistance. They are parallel combination. So 1 into 2 by 1 plus 2. Then see how much we get. So 2 here 3 times. Remaining is now 8 by 9. Right? It is 8 by 9. Then see last combination. So voltmeter. These two are parallel and capacitors also in parallel combination. Again, across the capacitor combination, these are in parallel combination. So capacitor parallel means C1 plus C2, that is 6. And these two are parallel combination. So R1, R2 by means 1 into 2 by 1 plus 2. So it is how much? 4. So 4 microseconds, right? So simply we have to focus. Whenever we want to calculate time constant, find effective resistance across the capacitor by removing the battery and connect by conducting wire. Okay, that is what we call short the battery. Okay, see next one. Let's see the question. A capacitor is a charge using an external battery with a resistance X in series. The dashed line shows the variation of ln I with respect to time. If the resistance is changed to 2x, the new graph will be so capacitor. There is a battery which is having resistance, means it is RC circuit. Okay, right. So resistance is doubled. How graph changes? Let us see calculation. So first of all, say charging. Charging means how Q value changes. So Q equal to Q naught into 1 minus e power minus t by RC, or you can write t by tau, where tau stands for time constant. Okay. Now in this case, tau equal to RC. Okay. Next, now differentiate this, and in the place of Q naught equal to, that is equal to C into V, right? Maximum charge on the capacitor. Otherwise, take a diagram here. This is a capacitor, and there is a battery having resistance. So I'm taking V as battery's EMF and R is its resistance. C is a capacitance, right? Okay. Now differentiate this to get current. So current equal to, in the place of Q naught CV, derivative 0 minus, it is a minus 1 by tau, means minus 1 by RC into e power minus t by tau. Okay. That is equal to, C gets cancelled. I equal to V by R e power minus t by tau, right? This is what we have discussed while discussing charging of capacitor, right? In the last lecture. Now in this, we are given a graph, right? Taking ln I. So take now log on both sides. Ln I is equal to ln V by R minus 1 by tau, means 1 by R. So it is T by RC, right? It is now just like y equal to mx plus c. This is c minus m into t, right? So this is of the form y equal to mx plus c, negative slope, positive y-intercept. And if you see, when resistance is doubled, if resistance is doubled, this y-intercept will decrease. Okay, that means we can guess options either P or Q, right? Since R is a double, y-intercept has to decrease, either P or Q. Now to decide out of those two, which is the correct one, now focus here slope. Slope is, slope is now minus 1 by RC. Our focus, the numerical value is 1 by RC. When R is double, the numerical value will decrease, right? And see for which one it is now less. So we can say that for Q, slope is now, you can say Modulus of slope is less, right? For Q. That means option is now Q. Okay. So just take now I equal to. Since graph is given for ln I as a function of time, so we have taken ln on both sides and man just compare it. Okay. See next one. Let's see the question. In the given circuit with a steady current means capacitor is fully charged. Okay. It means no current flows in this branch. Okay. So whenever asking steady current, we have to keep in mind capacitor is fully charged. That means the branch which contains a capacitor, there will be no current. So current flows only in this branch like this, only in the outer part. Okay. The potential difference, the potential difference across a capacitor must be, let's say how to solve it. It's asked for 2 marks in 2001. First make a diagram for that. So there is one battery, resistor, next one more battery, capacitor, and again a battery and resistor. See the values given V, R, V, this is C, 2V and 2R, right? So condition is now in steady state. So steady state, there is no flow of current in the branch, right? So focus now how to calculate current in the remaining branch. So let us take current is now anti-clockwise. So I'm taking here Kirchhoff's second law. If you are knowing directly, we can write current. If you are not knowing, use Kirchhoff's second law. Okay. Suppose starting from here, I'm taking now anti-clockwise. See carefully. Plus 2 minus IR minus I into 2R. See, we are moving along the current flow and current flows from high potential to low potential. That's why I have taken minus here. Next, again along the current flow. So minus I into R. Next, moving from high potential to low potential. So this is 2V. So this is minus V equal to 0. Then see what is the current? Current equal to 2 IR and IR, 3 IR, that is equal to V. So it is now V by 3R, right? That is now current flowing. Now see carefully, potential drop, potential drop across the resistor here, across this. See how much? Let us take this as A and this as B, okay? And this is now take it as D. Across B and D, potential difference. Across BD, potential difference equal to current is V by 3R, resistance is 2R. Okay. So R gets cancelled. It is now 2V by 3. That is now potential drop. That means across AB, across AB, across AB, potential difference will be 2V minus 2V by 3. See carefully. So we got potential drop across BD, that is 2V by 3. Now I am calculating across AB. Across AB, how much means 2V minus 2V by 3. 3 to 6, 6 minus 2, 4. It is a 4V by 3. That is now potential difference across AB. That means between these 2 points, potential difference is now 4V by 3. Okay. Now let us do one thing. Let us consider this is a potential is 0. If this potential is 0, so this potential must be 4V by 3. Check it once. Between these 2 points, potential difference equal to 4V by 3. If I am taking this is 0, this must be 4V by 3, right? Now we want to calculate potential difference across the, it is across the capacitor, right? Across capacitor means, let us see carefully. If this is 0, this will be V. Am I correct? This is 0, then this must be V. When this is V and this is a 4V by 3, so potential difference how much? So potential difference across capacitor, that is equal to 4V by 3 minus V, that is equal to V by 3. That is the answer, right? So first we are finding what is current, then finding potential difference across this combination. Remain just a calculation part. Okay. Let us see next one. Right, see what is given. Calculate the steady state current in the 2 ohm resistor shown in the circuit. Steady state meaning is capacitor is fully charged. That means no flow of current in this branch. Okay, that means we should not take now this resistor. So current flows only in this part. I think directly we can say here 2 and 3, they are parallel combination. So effective value 2 into 3 by 2 plus 3, right? Let us make calculation. I think directly we can solve it. See what is given here. 2 and 3. They are in parallel combination. 2 and 3. And capacitor is here. And here resistor. And for us, these values also not required. What is the value of capacitance? What is the value of this resistor also not required because no flow of current across this. Okay, next. This is a battery of PMF 6 volt. Resistance equal to, this is now 6 volt. Resistance 2.8 ohm. Okay, and for us, these values are not required because current flows only in the remaining part. So current flows now like this. It is I like this. Effective value, see how much here? It is 2 into 3 by 2 plus 3. So 6 by 5, 1.2, right? So current equal to 6 upon 2.8 plus 1.2. 2.3 and this is a 4, right? 6 by 4, that is 3 by 2. Okay. And once that current reaches this junction, now current divides because they are parallel combination. So V equal to I into R. V value is same for both. Therefore, I proportional to 1 by R, right? And we want to find out the current now through 2 ohm resistor, right? So through that current equal to, I'm taking as I2, that is equal to total value 3 by 2. It divides in the ratio 3 is to 2, right? So into 3 by 5, right? It is in the ratio 3 is to 2. So total 5 parts. Out of 5 parts, 3 parts will be through 2 ohm resistor. So this is 9 by 10, right? So that is the answer. Okay. In next lecture, we can discuss remaining problems.